So in this video, we are going to talk more about doubling time and half-life. Okay, but we're going to be a little bit more specific this time. This time, we're going to want to reconstruct the exponential function if we're just given the doubling time or half-life along with the initial value. So again, if we are given the initial value and we also know either the doubling time or the half-life, we know those things, check. Can we get this whole function back? And of course, if you look at it, the only part we're really missing is the r, okay, the relative rate of change. So the question boils down to, if you know the doubling time or half-life, can you get the r? And if you remember from previous videos, you should know that the answer to that question is yes. For example, in the case of doubling time, you know that the doubling time is equal to ln2 divided by r. And so using this formula, you can solve for r, and you get r is equal to ln2 divided by td. And there you go. So you take that r, you plug it into the exponential function. Of course, you'll have to plug that into your calculator first to get a number, and you put it into this formula to get your exponential function back. So let's do a quick example, and notice you really only have to do a doubling time example to know how to do the half-life example, because the only thing that's going to change here is the 2, right? That's going to change to a 1/2 when you do a half-life example. So let's go ahead and move on to an example. So let's say you have a bacteria colony and it's initially 10 cells large, and it doubles every 0.1 second. So it's growing pretty fast. Again, the goal is to find the exponential function that has these two things, this initial value and this doubling time. All right, so if we go straight to the formula, we remember that r is equal to ln2 divided by the doubling time, which is 0.1. And you straight up plug that into your calculator, you get 6.9315. And so you're basically done, because P of t is going to be equal to 10, that was already given to you, that's the initial value, times e to the 6.915 times 6.39315, my bad, and that's your answer. Okay, but let's say that you forgot the formula. Okay, you forgot this formula right here. Okay, how can you still do this problem? Well, if you forgot that formula, you have to at least remember, what does it mean to be a doubling time? Remember, in order to be a doubling time, it means that when you plug it in to the exponential function, you get twice what you started with. So now just plugging everything in, plugging 0.1 into the exponential function means you have 10 times e to the r 0.1. Let me just highlight r there in purple. There we go. And you want to solve for r. So you divide both sides by 10. You get e to the r 0.1 equals 2. You take ln of both sides. You get r times 0.1 equals ln2. And so you go back, so dividing both sides by 0.1, you get the same exact answer as before. ln2 divided by 0.1. Right? Whoa. Computer. So r equals ln2 divided by 0.1. That's the same as last time. And you get 6.9315. You plug it into the exponential function and you're done. Okay, so here are two ways to do it. One is if you remember the formula, another is if you don't. If you don't, then you need to at least know the doubling time. And that's it. So let me just write down ln2 divided by 0.1, if it will allow me that. And it did, finally. And you see, that's going to be the same exact thing as 6.9315 that we got previously, and so you could plug it in. Okay, great.